Thank you. Thank you very much, guys. Yeah, it sounds like I can hear myself. You must be able to hear me. So we are, I'm Matt, and this is Dan. Let me find my pointer. What are we here to talk about? We're going to talk about Reactive Trader Cloud, which is something that a couple of my colleagues came to Barcelona a couple of months ago to talk about, Chi-Ming and James. They talked about Reactive Trader Cloud and how it runs on .NET Core and how it runs in Google Cloud and the front end and the WebSocket push and all that sort of stuff. But today, Dan and I are going to talk much more specifically about event sourcing. So Reactive Trader Cloud has been put together with an architectural style called event sourcing, and in an hour you're going to know all about that, and hopefully you don't know too much about it right now. And we are using event sourcing not just on Reactive Trader Cloud, a little toy open source application, but also a big, angry production app that Dan and I and a few other people that are here at Adaptive are building at the moment, which has got 24 developers on it, 50-odd people in the project overall. Many, many years of development have gone on, and still more to come. And so we're learning a huge amount about how to build an architecture like this, and what we did in Reactive Trader Cloud and how it scales up. So this is photos, but we're here in the flesh, so it's a bit more exciting. We are from a company called Adaptive. Albert gave us a pretty good example, pretty good introduction. Thank you very much, Albert. We've been in Barcelona for a little over a year. We've got offices down in Poblenou, and we are about 15, 20 people in Barcelona at the moment and looking to grow more and more. We have a range of projects that are happening in our Barcelona office, really exciting things, and the style of thing we're going to talk about right now is exactly what we build. So, Reactive Trader Cloud is, do you want to stand there? Reactive Trader Cloud is a open source application of ours that we put together so that we could come to conferences, user groups, evenings like this, and talk about how we build what we build. Because most of the applications that we build are commercial applications that are behind NDAs or internal applications that we aren't allowed to talk about too openly. So Reactive Trader Cloud, even though it's quite small, it's open source. You can go and look at it and understand it in, I guess, about half a day. If you went through all the code, you could understand the whole thing front to back. It really does take the same architectural approach and style to how we build our big applications that have 20 developers on them working for a couple of years. So a lot of the patterns that you see in the small, when we scale them up, they're still true and it still makes sense. And so Reactive Trader Cloud is what we call a foreign exchange single dealer platform. So a foreign exchange, we probably all know what that is. Foreign exchange is just the act of taking your euros and going to Britain and buying right now a huge amount of pounds with them, thanks to the British political system. And it's that transaction that I did on the way down from London to here, when I got very few euros for my pounds. But it's that scaled up to the entire corporate and institutional market. So whereas I bought a couple of £100 worth of euros, people are selling and buying and selling millions, if not billions, and actually the FX market is a $1 trillion business on a daily basis. So you go from me buying a bit of spare change to buy some dinner and some drinks when I'm in Barcelona, to Apple moving all of its foreign exchange money, all of the euros that it made in the last month back to America, into US dollars, for example. So it scales all the way up and down. And we build FX STPs for our clients. But what is an FX STP? So we've actually got one that we prepared earlier that we can show you a demo of. So this is an FX STP. It has some pretty simple components that you see in every FX STP. Pretty much every investment bank, foreign exchange firm, will have one of these that they build and give to their clients. So what does it break down to? It breaks down into a few really core key components. We've got pricing here, which is all the prices being sent from the server running in Google Cloud to the UI. We've got the ability to do a trade. I can show you how to trade by looking down here. So we do a trade. You saw a flash in this part of the system down here, of the app down here, which is the blotter. The blotter is just the record of all the stuff you've done, nothing more sophisticated than that. And then over here on the right-hand side, you have the analytics. So this is keeping a track, if you're a trader, of when you've purchased some amount of New Zealand dollars, for example there, when I took my US dollars, bought some New Zealand dollars, and then held on to my New Zealand dollars, presuming that I wanted to trade them back into US dollars at some point in the future. This tells me if I've made money or lost money. If you're just like me, coming to Barcelona to have some drinks, you're going to spend it. I'm going to spend it on beer and food, guarantee it. So I'm not going to have any to take back with me. But if you're a trader or an investment bank, you're sitting in the market, supplying your customers with flow, with giving them liquidity, and allowing them to do the transactions they need, but you're also trying to make a bit of money out of it, or else you can't stay in business. And that is what we see on the right-hand side. So this is the UI, and when we start talking about, in a couple of slides' time, how we mapped the UI and the functionality to an event-sourced architecture, you'll see that the components that we broke it down to map really closely to the UI. And interestingly enough, what you find is that these components actually map really, really closely to parts of the business that are inside the organization. So if you excuse me trying to work a mouse. So we've got three distinct components of the application, and this is actually pricing and trade execution, and they really do map to different parts of the organization. So one of the really nice things about event sourcing and CQRS is that you get to split apart your application into the parts of the organization that you're serving, that you're building the business functionality for. And here you can see the app pulled apart into different pieces that really do map to the organization. There is definitely, inside very large investment banks, a whole organizational unit, probably 200 people, responsible for getting those numbers onto the screen and nothing else. Then there's another part of the organization, maybe 50 people, that are responsible for what happens when you click. Then there's probably 1,000 people responsible for all of the stuff down at the bottom of the screen. In a proper application, you could right-click on one of those trades and you could do a whole lot of actions to them, what you call a post-trade amendment. So you could, well, I'm not going to get into what you could do, but there's 4 or 5 different things you can do to an FX trade that require a huge amount of back-end support and processing. And on the right-hand side, well, there's probably 500 or so people just responsible for generating the analytics, providing market commentary, math libraries, quant libraries, all that sort of thing to provide you with a really accurate view of what your investment is going to do otherwise. So we've broken apart the application, and it really does map to the parts of the organization that you serve. I've spent I've spent quite a few years building complex applications and trying to figure out how to map the stuff that I'm building when I'm sitting in an IDE and writing code to the part of the organization that is responsible for it. And until we started using event sourcing, I really struggled with trying to keep them all apart because everything kept getting smushed together, and it was really, really difficult. So now that we've seen what the app looks like, let's piece this back together so that Dan can use it later on. Here we go. So what does Reactive Trader Cloud, if you take it off the screen and stop looking at it in a web browser and you look at it in an architecture diagram? Well, what you see is these different parts of the application that I just talked about broken out into components. So we have trade execution, which is where you click and do a trade. Reference data, that's the set of currencies that you're able to trade. Prices, the price feed is the prices moving up and down, the numbers that you can trade on. Reference data is, again, the currency. So we've written into EventStore the currencies we can trade on. Now we can read them out. The blotter is showing all the trades that have happened in the past. And analytics is showing the P&L and the graph and charts on the right-hand side. So it's really nice that if you go to this GitHub repository and you have a look at the code base, which is in .NET, so it's everyone here will be able to understand it. The code matches the diagram, matches the UI, and it matches the organization, which is pretty cool. Dan.
Hello. Can folks hear me? Nope. Hello? Can you hear me now? Cool. So my name's Dan, and I'm a server-side developer at Adaptive. So I'm just going to go into a bit more detail in the topics that we're going to cover in this talk today. So the app you've just seen, we're going to talk about the server-side technologies that we use. We're going to give some background on some of the design concepts that we've used in Reactive Trader, which are event sourcing, domain-driven design, and CQRS. We'll also talk about how we can implement process managers, which are also known as Sagas, which some of you may or may not have heard of, to coordinate a business process in a robust and resilient way. We're also currently working on a real-world project at the moment, which is very large and complex. We are using these technologies. So we're going to talk a bit about our experiences working on that project and some of the lessons that we've learned along the way. So talking about some of the technologies that we use, obviously we're using .NET Core. So the backend is completely built using .NET Core version 1.1 at the moment, but there are plans to move to version 2 in the future. We're using EventStore. So we'll talk more about that in a few slides' time, but this is like a functional database, and it fits in very well with event sourcing, and it has builds for both Windows and Ubuntu, and has a .NET Core client API. We use a tool or technology called Crossbar.io, which is an open source message broker. We use this to sort of communicate between the different components of the system. This is built using what's called Web Application Messaging Protocol, or WAMP. And to sort of use Crossbar.io, we use an open source project called WAMP Sharp, which is a C# implementation of WAMP, and it provides both the client and server roles. We also use reactive extensions, which a lot of you in here may have heard of. These type of applications are all about streams of data, and reactive extensions fits in very nicely with that technology, or with those design methodologies. And the cool thing is that all of these technologies are completely open source, and they're available to start working with today. Okay, so talking a bit about event sourcing. So there's three things really that I wanted to talk about with event sourcing. The first one is that state is stored as a series of events. Storage is append only, and it's a functional database. So in terms of state being stored as a series of events, so in more traditional systems that are built on top of a relational database, we have what's called CRUD operations, or create, read, update, delete, which many of you have heard of and worked with. So you can imagine we had a customer entity. We might have a table in the database called customer. We might have a bunch of operations that might be stored procedures, things like create customer or update address, and things like that. So the thing is, with this style of system, when you update data, you're mutating that data. So if we called a procedure called update address, we're actually changing the contents of that table and persisting that changed state. If we did have something like update address, one of the questions that somebody might ask is, well, why did that address change? Did the customer change it because there was an incorrect spelling in the street name, for example, or did they change it because they've actually moved house? So in domain-driven design, we have what we call domain events, and the idea is that we capture the intent of what actually happened. So in a sort of event-sourced system using domain-driven design, we might have a customer moved event or an address changed event. So we capture the intent of what actually happened. So going into a bit more detail of that. So you can imagine that same data, how we might represent that as a series of events. So the first event might be customer registered, which is something that happened in response to the customer signing up to your system. That event would have a payload, and that payload would contain all of the data that you see there customer entity on the right-hand side. So a little bit later, the customer may actually move house. So there might be some user interface in the system where the customer can actually record that they're moving house, and then an event would be raised in the system called customer moved, and you can see that the address there is changed to the updated address. And then a bit later on, the user may actually change their email address for one reason or another, and you can see there that the email address has been updated, and then perhaps the user got tired of the system and decided to close their account. As you can see, we don't go back and delete events, we just append a new event called customer account closed. So, which brings us to the next point, that storage in an event store is append only. So when I say append only, it's an append only log of facts. New events are only ever appended to that log and nothing is ever deleted. So for example, with a customer account closed, we just add an event there. So this way, we always have a golden source of truth in the system, and valuable business meaning can be derived from that source of truth, even well after the system was originally designed and developed. For example, the business may need a report that answers the question, how many customers have moved house after 3 months of signing up? And you can easily derive that information from this source of truth. So, and in traditional systems, you can of course do this as well. But when you're using a relational database management system, you need to factor that into your design and development, and there are many different approaches. For example, triggers for auditing is one approach, whereas this is really a first-class concept with event sourcing. It's also great for debugging. So if you had a bug in production, you could actually get a copy of those events and then play them through into a development environment with exactly the same code base running in a development environment, and just play those events in and actually watch what happened and find out why there was a bug. The other point is that an event store can be considered as a functional database. So if we have a function that takes two inputs, the initial state and an event, and then gives you some new state, we can basically build up our current state by nesting those function calls. So for example, with those 4 events we just saw, the very first function call would be the customer registered event with the initial state, which would just be an empty customer object. Then that would give us a brand new customer object, and then that plus the next event would serve as the input to the next function call. So you can keep nesting these function calls and build up to your current state, and those of you who are involved in functional programming might know this as a left fold. So taking a bit of a step back and talking about events, events really are a type of message in the system that sort of says something interesting in the business happened. And it's also probably worth mentioning at this point that events and commands are not strictly a DDD concept, though many systems that are built using DDD will use events and commands. So in DDD, things that affect or change the state of the system are modeled as domain events. So in that way, events can be described as messages that represent something interesting that happened in the business. And they're always named in the past tense, so like customer moved or address updated or something like that. Commands, on the other hand, are an instruction, so a request to our domain to do something. And they're always named with a verb in what's called the imperative mood. So basically do something like move house, change address, etc. So they're an instruction to our domain to actually do something. And so that leads us to aggregates. So how do these events actually get into the system in the first place? So when we talk about aggregates, aggregates are a group of related objects that form a consistency boundary. When we say consistency boundary, it means that everything that the aggregate represents must always be in a consistent state. Aggregates are sort of a entity where business rules are enforced So any change to the domain always happens through the aggregate. So in other words, they're like a gatekeeper for our domain. And so we talked about events and commands before. So aggregates apply commands and raise events. And when using event sourcing, those events are actually added to our event store in an append-only fashion. So in that way, we can view an aggregate like a function that takes a command and some state and then outputs one or more events. So going back to our example, it probably makes sense to model a customer or a customer account. We might call it as an aggregate, and we can see the commands going into that aggregate: register new account, move house, close account, and then the events that would be raised subsequently after processing those commands. And over to Matt.
Cool. Thanks, thanks, Dan. So we just talked about events, commands, aggregates, DDD, did we mention CQRS yet?
Not yet.
Not yet. Okay, that's coming. So we've just introduced a whole bunch of concepts, and it's really hard. When I started first learning about event sourcing 2.5, 3 years ago, I really struggled to put all these different concepts into something that made sense in my head that I could reason about. What we've done with Reactive Trader Cloud is hopefully break down the concepts and make them really straightforward and easy to understand. I think a good way to think about the benefits of event sourcing is to think about how it makes what looks like quite an intimidating and complex problem actually quite simple when you break it down to its smallest parts. So if you think about how many events make up the application Reactive Trader Cloud, that's a number. We can go and look in the code base and figure it out. If I think about what the relational database structure would look like, I end up with, in my head, quite a complicated structure with maybe 10 or 12 different tables. If we think about how many events there are in Reactive Trader Cloud, there's 3 different types of aggregates, which we're going to talk about in 2 seconds, and then there's about 7 events in total. So there's only 7 events that make up all of the complexity of the application you just saw, which to me makes it seem really uncomplex and really simple, because you can really easily keep 7 events in your head and reason about what they do and where they flow and how they interact. So those events, okay, so if I stand right on the corner of the stage so you guys can see the screen. So we've got currencies. Currencies are pretty clearly a first-class concept in an FX single dealer platform. A currency is euros or US dollars or British pounds, New Zealand dollars. A currency pair is simply an instrument, a description of something that you trade when you're buying or selling one currency into another. And so we have a series of events that you use to put the currency pairs into Reactive Trader Cloud for the first time. So we have currency pair created, currency pair activated, and currency pair deactivated. We need to separate out the concept of activation from creation, because you can have currency pairs in the system that you aren't currently allowed to trade on. So you need to be able to deactivate them, which means you also need to be able to activate them the first time round. If we look at what a currency pair is, well, it's a bunch of attributes, some facts about it, and then the activation and the deactivation is really simple. It's just an event that literally captures the intent of what you're doing, or what it means when you see it in the system. It means euro dollar was activated or deactivated, and enough information to tell you about the currency pair that it applies to. So really, really straightforward. We have events related to trades. We have a trade created event. Now this trade created event is the most complicated event in the system, and it wraps up all of the information you need to know about the trade. So it has a trade ID, so you can refer to it later on in other systems. It has the name of the person that traded, the currency pair that they traded, the rate that they traded at, the date they traded on, the value date of the trade, whether you were buying or selling, and how much you bought and sold, and what that number is actually denominated in. So that's an FX trade. It's like seven or eight different attributes and a few events. So you can try to create a trade, the trade can be rejected, or the trade can be completed, and that's it. And from those small events, not very complicated, you could probably go leave the meetup and go home and or go to work tomorrow morning and write them down again from memory because they're not that complicated. You'll be able to rebuild the system. We have one last set of events related to credit accounts, which are in Reactive Trader Cloud, so that we can talk about process managers and the challenges of modeling things in EventSource world. But these are 3 more events talking about you can create a credit account. A credit account is like the amount of money you have in the bank that you can draw down on. It's how much money is on your credit card. It's exactly that. And when you try to buy something, you either use up some of that credit, so you have a credit reserved event, or you've spent too much money and you can't buy it, and so we record the fact that you breached your credit limit. If you only had 100 euros on your credit card and you went out for a really nice dinner, you would have a credit limit breached event when you tried to pay, but if you went out for McDonald's, you would be able to pay, so you just have a credit reserved event. Pretty straightforward, very simple concepts. So those are events, and I think the thing that we want to get across in this talk to people who are just getting started with event sourcing and are maybe coming across it for the very first time is that these events aren't intimidating things. If you think about the important facts about the business problem or the domain or the concept you need to model, just put them into the event. It's really straightforward. If we were talking instead about relational databases and someone was arguing about fourth normal, third normal, second normal form, the fact that you have, I've worked on databases before where just this line, the representation of a point in time, would be 5 different tables. One for the year, one for the month, one for the day, and people take this stuff to the nth degree and make the systems they work with really unpleasant to use. But with event sourcing, just write it down and don't overcomplicate it. And what you're left with is really lightweight, easy to understand event schemas, Dan.
Right, so those events you just saw, obviously they have a schema, so a well-known format to adhere to, and really this is basically like a message contract. So obviously you can define this message contract early on, and it means teams can work in parallel. You can have a sort of a service component being built that consumes an event in parallel with the service that might produce that event. An important sort of decision to make when designing your system is whether you have a code-first schema or a sort of schema-first schema. So when I say code-first, you can use tools like JSON.NET and just use its object serialization to write out the shape of what those events look like, which is great, and that probably might make sense if you're working on a small system. But something that we need to be aware of is that you can kind of break things very easily. If you just, if you're using ReSharper, you can refactor something very easily and check in some code, and then that just completely breaks a downstream component that's consuming that event. So in that way, you sort of, even though you don't have any physical binary coupling, you have an implicit binary coupling. So if you have a very large system, it's definitely worth having a schema-first design. We've definitely found that useful in our project. Back to command query responsibility segregation, CQRS. So this is the diagram that Matt showed before of Reactive Trader. Really, it's just, you can see on the top there you've got the...
Do you want to introduce command query responsibility segregation a little bit?
First?
Yeah.
Okay, yep. So we can see at the top there we've got write, and at the bottom we've got read, so we'll talk about that a bit more. And so some of you may have seen this diagram from the Microsoft online book called CQRS Journey. And really this is just highlighting the flow of things from the write side all the way through to the read side. So CQRS, it's a natural fit with event sourcing, but not all systems that use CQRS need to use event sourcing, and CQRS isn't necessary when using event sourcing, but it's a really good fit. So with CQRS, we separate our commands from our queries using separate interfaces, and this separation allows us to use separate models to update data than what we use to query data. In a more traditional sort of n-layered type system, where you kind of have your database, then your data access layer, then your business logic layer and things like that. Quite often, any changes, if you need to make an amendment to the way something is written, you can quite often break the way things are read, and vice versa. With CQRS, it allows you to completely separate the read and the write side and alleviate those issues. And separating commands from queries can have several benefits. So we can have separate streams working on completely different parts of the system. For example, somebody could write the blotter that you just saw, and somebody could actually write the service, the trade execution service, completely separately. So it allows separation in that way. It also allows for separate performance tuning. So if we find that we're not writing very much, but we're reading a lot, we can scale our read side completely separately to our write side, which is really cool. So back to that diagram, I mean, it really is basic, but you can just see very clearly there we've got our write side at the top there that actually write things into EventStore, and our read side that read things from EventStore. And over to Matt.
Cool, thanks, Dan. So when we started the big project that we're on at the moment, Dan and I are on at the moment, was the first time we'd picked up event sourcing and started using it in anger. A couple of people on the team had worked with it previously, but in much smaller projects, and so we were getting into it for the first time in a really big way. And we had now, after the hindsight of a year and a half, there's a lot of things that we got wrong when we started that we would be able to avoid if we went back. And a lot of them are about, I don't think there's things we could have done, a lot we could have done differently. There's some things we could have done differently, but approaching a system architecture in a completely different way is a journey by itself. And it's something that the whole team has to go on. So we as developers needed to learn how to think about approaching the problem in an event-sourced way. But when we were sitting there talking to business analysts and even some of the more sophisticated users, it was really apparent that everyone thinks in a relational database way. Everyone has been exposed to relational databases enough in the last 40 years, 45 years, that they think, well, and also Excel, which is a relational database on screen, everyone thinks about it in those terms. All of their problems come to you as relational database representations, even before they've realized they've made a solution out of it. Which means what you're doing when you're developing an event-sourced solution to a problem is taking what you think is a business requirement that is actually a database schema that someone's implemented in their head and described to you, and turning that into an event-sourced system. It's quite a lot of awkwardness around the impedance mismatch. And we've spent a lot of time taking the BAs with us on understanding what it means to talk about domain events and the other attributes of an event-sourced system, rather than just talking about the relationships between customers and their orders, or trades and the things that you need to deliver from the trade. As an example, people have got in their heads all the constraints of that a relational database lets you enforce. So relational integrity, you can make sure that if you make a change here, that this other part of the system, which has a foreign key linking it, is updated in the same transaction, and that the whole system remains consistent every time someone runs a query against it. Event sourcing throws all of that out the window. So event sourcing and CQRS give you eventually consistent systems. If we look at this diagram, you can see that when we make a change to the system here by submitting a command, the user making a change in the UI, it flows through, in this diagram, 4 or 5 different boxes. If you think about those boxes as different systems, they're definitely distributed on opposite sides of a network from each other, of a network connection. That means that no matter how fast the system is and how low latency the network connections are, when a user clicks a button to submit the command, it can take some number of milliseconds, If you're lucky, less than 125 milliseconds, so it appears instantaneous. If you're unlucky, up to a second or a second and a half or 2 seconds to come back around and the user to see the result. In that period of time, there's an opportunity for someone to do something that affects a change on an outdated version of the system. In a relational database where you aren't doing CQRS and your query about the system happens on exactly the same path that your write to the system happens, you will see nothing. You'll see the system be locked. And if someone else issues a read, they will get in line in the database to queue either before or after the transaction to get a snapshot of the system, which means they might see an out-of-date view of the system, but when they go to issue a write, they won't be issuing it against an out-of-date view of the system. And that was really difficult for us to get across to people. The constraints that people have in mind, all of them are relational database constraints. And in an event-sourced world, you can't do any of those things. It means you need to approach problem discovery, so figuring out what the system should actually do and how it should be modeled in a completely different way. You might have heard of event storming. Event storming is a way to model event-sourced systems in a sort of collaborative way. You get all the business stakeholders into a room, you have a big long wall. That wall is a good example of a big long wall. And you give everyone post-it notes and you go out and stick on the wall the different things that happen in the system. And you try to stop people from modeling the relationships and the rules and the bits of constraints that need to be enforced between the different bits of data. You just get them to talk about what happens. And you try to turn that of what happens into your business events and try to stop people running down the road of just giving you a relational database answer to your question of what does the system do. And it's really difficult. Interestingly enough, if you can actually talk to just the users of the system who have never been exposed to SQL and maybe don't really like using Excel, you get the right answers. It's all the layers that our software development industry has put in the middle of people who have learned all about relational databases over the last 25 years of building software that put all this noise in. The users that are just using the system and want to talk about things to the developers that mean something to them are really good sources of information. But without access to those users, then it doesn't really work very well. So once you have figured out what you think are the requirements and hopefully teased apart the bits of the problem that someone has told you about that just require a relational database and have got down to the event sourcing view of the world where you're just talking about things that happen and we need to record them because they're interesting, you get to the modeling challenge. So if we had had a relational problem, if we'd had a problem described to us in relational terms and now we needed to model it, well, we just need to put it into the database as people told us about it. But modeling aggregates, which are the unit of discourse in an event-sourced world, which Dan just talked about, is really weird compared to modeling relationships. And we've been doing it for 2 years, and it still takes a while when you approach a new domain, a new area of the application, some new requirements to be able to think about it in the proper way. And the way I think about it now is that instead of thinking about relationships between data and what needs to be kept in sync or made consistent with each other, I think about the ownership of data and what other data it needs to be kept consistent with. So who owns this bit of data? What other bits of data will change with it at the same time? Which is easier than thinking about all the relationships between all the entities in your system. As we were building the system we're working on now, we discovered that we got to delay a lot of decisions, which made our life as developers really easy. Dan made the point that you get to separate your right side, so the side of your system that is concerned with updating the domain and handling requests to do things and book trades and update customer addresses, from the side of the system that lets you view customer addresses and understand what trades you've already booked. Splitting them apart means you can work on storing them, writing them in the appropriate way, completely separately from representing them in an appropriate way, from reading them back and displaying them to the user, which means you don't have to make those decisions at the same time. For every time, if you had to make them at the same time, what you are forced to do is model your relational database in a way that lets you query it at the same time to give you back the information you want to display to the users. And it's really awkward to do that. I'm sure if you guys have ever done any SQL development or you worked with a database and picked up someone else's relational database that has been built up over the years and tried to answer a seemingly simple query from a business user, you can really easily end up with a query that has 5, 10, maybe a dozen joins on it. It's like this long, with lots of wheres, lots of filtering. It's a nightmare to build up, debug, use. With event sourcing, all of that goes away because you haven't coupled your ability to view the system from the structure you've stored the system in for writing to. And it's really, really easy. So you get to delay those things. But you have to choose about what parts of the system live with the other system, with other parts of the system. And that can be quite difficult. We found that for our project, where we had built, we'd split 20 developers into 4 or 5 streams. So each development stream, we are using Agile, so we have a Scrum team of 4 to 5 people. They are working on distinct, separate, deployable units of the application. And we made those decisions about how to split things up on day 1 of the project. Well, guess what you know on day 1 of the project about the project? Nothing. So we got some of those decisions wrong, which means that as time has gone on, some of the boundaries and the relationships about the behavior of the system and what happens and why something happens in relation to something else are really awkward for us to work with now. And we're now a year and a half into the project, and some of those decisions are starting to catch up with us. So we're thinking about whether to go back in and change the models and pull things apart and reconstitute them in different places. But at no point do we think we're going to change the event schemas. Interestingly enough, we've very rarely got an event schema wrong. We've invented 50 event schemas, maybe more than that, and I think we've got 1 or 2 of them wrong and had to go on back in and add something in the past, that's really impressive. So you get the event schema right, but maybe the event lives in the wrong aggregate and is a representative of the wrong part of the system, which is, again, it's a totally novel challenge and not what we expected to happen when we were going through all this. So the points are, sorry for laboring the point, but I wish someone had told me this a year and a half ago. Events and processes are more important than data and relationships, because the processes are what happens in the system, and it's what the business owners think about and your users are concerned about, and the events are the facts about those processes, and they are far more important than the data and the relationships. And so talking about processes leads us on to process managers.
Right, so process managers. Some of you may have also heard of these being called Sagas. So process managers are sort of entities or a sort of artifact, I guess, in your system that coordinate business process. When we say process, that may be a long-running process, like something that goes over a few days, maybe, or even months, to a process that might be very short-lived, maybe even less than a second. So we talked about aggregates before, and aggregates are very isolated. They take care of themselves. Like, for example, the customer aggregate takes care of things like updating an address, moving a house, closing an account. It's very separate. So aggregates are they're responsible for applying commands, as we said before, and then raising events. Process managers are kind of the inverse of that. So process managers are responsible for receiving events and then dispatching commands. So they're kind of like, they sort of sit between aggregates. So if you have some sort of business requirement that spans multiple aggregates and you have some kind of process, then the way you would solve this problem is with a process manager. So we talked about events and commands being messages, and as a lot of us know, in a messaging system, we have some issues. We have 2 main issues, really. They are duplicates and ordering. So there's no such thing as receiving a message exactly once, only once. There are, you quite often you'll get duplicates, and also ordering. Like there's no real guarantee that you receive messages in the correct order. Things are received out of order sometimes. So with the process manager, you can model that as a state machine which can handle both duplicates and out-of-order messages. So, for example, if an event is received out of order, a transition to the next state can be denied until the first expected event arrives. And for duplicates, even if the same event, if one event triggers a state transition, receiving that event again, I mean, you're already in that state, so it doesn't matter. So in that way, a process manager can deal with those issues in a messaging system. So also, when we use EventStore, as we talked about aggregates before, we essentially save down the series of events that make up that aggregate. So that's how we persist our aggregate. Similarly, we can do the same thing for process managers. So we can save the series of events that are involved with a given process. So if we go back to the reactive trader example, as Matt talked about before, we have a couple of aggregates in our system. So we have a trade aggregate, which is responsible for dealing with booking trades and dealing with whether a trade should be rejected or done successfully. And then we have a credit account, which is responsible for checking, does this account have enough credit in it to book this trade? And if it does, it will raise a credit reserved event. If it doesn't, it will raise a credit limit breached event. But how do you coordinate that process? And you see the little box in the middle there is called Trade Execution Process Manager. And so you can see it sort of sits in between those aggregates there. So the arrows in yellow are commands and the arrows in black are events. So the first thing that happens when you click on one of those tiles is a book trade command is issued. That is applied to the trade aggregate, and then we get a trade created event. A completely separate part of the system, we have this trade execution process manager listening for events. It cares about trade created events. When it receives one of those events, it will say, oh, somebody's trying to book a trade. I need to go off and reserve some credit. So it will issue send a reserve credit command, and that will be applied to the credit account aggregate. And this aggregate, as we talked about before, is a consistency boundary. So either that account has enough money or it doesn't to book that trade. So we can check whether we have enough credit available. If we do, then as a result of applying that command, the credit account aggregate will raise a credit reserved event. If not, it will raise a credit limit breached event. And our trade execution process manager is also interested in those two events because it will respond to that event and then send a command saying to either complete or reject the trade. And then in response to that, the trade aggregate will raise those two corresponding events, trade completed or trade rejected. And you can see in that diagram that the aggregates are very isolated. They don't care. The trade aggregate doesn't care about any of the credit-related events or commands. It just cares about booking a trade and completing or rejecting the trade, and that's it. So it's sort of the process manager sits there and coordinates process in your system. And so I'll give a little demo now of, so in Reactive Trader, we have modeled that interaction as a process manager using EventStore. And I'll just give a little example of what that looks like. So how do I change screens here?
Question.
How do I get out of that?
Like this.
There we go. Cool. So I'll get. Just bear with me as I set up. Okay. So this little console window on the right-hand side, I'm just going to use that to. We use Kubernetes as our container manager, and we have Docker containers for each of the components. And I'm just going to run a few commands on the right-hand side here. I won't go into too much detail of all of that stuff.
So this stuff is just what Dan's getting set up. This web app is running on Google Cloud. It's not running on Dan's laptop. We are controlling the Kubernetes cluster that is hosting all of these executionable services. Dan, one thing I forgot to do earlier, if you just put the mouse over the little green tick in the bottom left-hand side.
Oh, yep. It's very hard to see from the...
So that's really hard to see. But you can see here that we've got, these are all the system components that are actually running in the environment at the moment. So those things, the blotter, pricing, reference data, broker, execution, and analytics map to that architecture diagram that we saw before, the right side and the read side. And they are, you can see alongside them a little number, and that tells you how many instances of them are running. So Dan's going to do something. I'm not going to ruin the surprise. But you'll see that when he does something, we see the numbers change and the behavior of the system changes in response to a failure or something going wrong with some part of the system, and there no longer being an instance running of a particular component.
So I'm just going to bring up another screen here, which is our web interface to EventStore. I'll come back to that in just a minute. So for sort of demo purposes in this application, we've configured a few things like some delays to simulate something taking a longer time than usual. And we have a specific currency pair here, which I believe is Euro JPY, which we've configured to take 5 seconds. The UI has a timeout of 5 seconds, so if I actually try and execute that trade there, you'll see it's pending for a long time, the UI times out, and then eventually it will move to the done status down the bottom there, which you should have seen just down here. So the ID of that trade there is 1702. So in terms of process managers, let's have a look at the events involved in that particular process. So if unfortunately this part of the UI is not reactive. So we can see we have 3 events there that were involved in the process of booking that trade. So we have the trade created event that happened first down the bottom there, a credit reserved event, and then a trade completed event.
Do you just want to click on the JSON link here to show people that we weren't making any of that up? So this is the event stored in EventStore, trade ID, trader name, etc., etc. Those are the samples that I showed earlier. This is exactly what is stored in the database. No more complicated stuff than that. Cool. That's all. Sorry.
So what I'm going to show now is the fact that our process managers, as we sort of manage a step in the process, we persist the events that we've saved into EventStore. And that allows our system to be resilient. So if a certain part of the system crashes, we've persisted the state of that process, and then when our system comes back up again, we can just resume running that process. So hopefully, if I'm quick enough with my mouse clicking, so on the right-hand side there, I'm just going to run a command that will scale the number of trade execution services down to 0, so that there's no services running. But before I do that, I'll go ahead and book. No, let me try that again. I'll book that trade. So eventually we should see that this little icon there at the bottom right has become amber, and we can see that the execution service is just not running. We can see that at the very top row in the bottom left blotter there, the trade is still in the pending state, and our UI has responded saying that the timeout exceeded, the execution state is unknown. It's probably worth noting that everything else is still running, so we're still getting price ticks come through, and every other part of the system is still working. We have disabled the ability to execute trades, so I can't actually click and execute anything because that service is not running. So if I go back over to my console now and scale back up to 1 instance of that service.
Which includes the process manager.
Which includes the process manager. After some time, the icon at the bottom right should go green. And because we've configured this trade to take about 5 seconds, after some time, we should move to the done state, and there we go. So basically, we show that our process managers can coordinate a business process that spans multiple aggregates, and we can use EventStore to persist the state of our process for resiliency. So different parts of our system can crash, we can bring them back up, and that process can continue. So that is all for the demo.
The demo god smiled on us, Dan.
And over to...
Cool. So once we had figured out, which took us quite a long time, how to get the requirements and do the modeling, we spent quite a long time not working with process managers because we came to them a little bit later on in the project. Once we had them modeling things with them, it became a little bit easier now that we were able to understand how to make these long-running processes work in an event-sourced world. But we still had a couple of other challenges. So one of those was the architectural challenge. So when we started the project, the client had no infrastructure, no development environment, no production environment, no software development environment or way to build and develop software at all. So we spent about a month when we first started, before we even got to the business requirements and started listening to users and figuring out what to build. We spent a month building our low-level infrastructure. So if you think about the low-level infrastructure involved in getting data into and out of a relational database, this is something I like to think about because I honestly think this is such a more simple way to build applications than using a database, and I hope never have to use a normal database ever again. But if you think about what an ORM is and how big and complicated it is, people have written books about NHibernate, which is the port of Hibernate, the Java ORM, that are like that. They've written people have written dozens and dozens of different object relationship mappers, all trying to solve their particular pain of getting their data in and out of a database and into an object-oriented world in a relatively simple way. So when we picked up EventStore and saw the APIs for writing events and reading events, we were really amazed at how straightforward it is. When all your data is JSON documents, it's kind of not surprising that without the API needing to understand anything about the structure of your events, it's really quite straightforward to write them into a database, into EventStore, then read them back. But that didn't stop us cocking it up and doing all the wrong things. The first thing we did was took our really simple, lightweight APIs to read and write data into EventStore and wrapped it up in what you could call as a framework. So a whole bunch of generic interfaces, classes, factories, all the things that you see in an ORM world that make it really simple to do hard things. We made in EventStore it really hard to do simple things because that's all getting data in and out of EventStore is. It's really, really straightforward. We spent a couple of weeks doing the wrong thing and then a couple of weeks tacking back over trying to do the right thing and making the way we've got data in and out of EventStore really easy. You can go and look at the read and write data patterns in Reactive Trader Cloud, and they are probably about 50% of the code that we have compared to what we have in our big full project. Our big full project has 20 developers, 4 different development streams, millions of lines of code, and the data access layer that we have in it is twice the size of the one that we have in Reactive Trader Cloud, and that's all we need, and it works. So the simplicity you get of persisting and reading back your data is absolutely amazing. But once we had the pattern for getting stuff into and out of it, we still needed to build some layers on top of it. On the right side, we have talked quite a lot tonight about commands, command handlers. Those are the things that take the commands, map them to an aggregate to see whether or not you can perform the command, and then tell the user the result of the command. Aggregates, that's the consistency boundary that we've been talking about, and process managers that we saw just a demo of. That's all the stuff on the right side. On the read side, we have a range of different things that you see in Reactive Trader Cloud as well. So you have in-process streaming dictionaries. So because EventStore it's streaming beyond anything else, you can set up a subscription to EventStore and be told about events as soon as they're written on the right side. And so it acts somewhat like a message bus in that it will call you back and give you updates about what's happening in the system. You can take that end-to-end reactivity and build data structures on top of it that let you push those updates all the way through to the UI. So one of the things we have inside Reactive Trader Cloud is something we call an observable dictionary, and that's a library that is available on our GitHub. It's an open source project that takes a traditional dictionary, so a key to a value, and makes it a key to a stream of values. So instead of asking for a customer in a dictionary and getting back the current customer that's in the dictionary, what you get back is a stream of customers that will give you a new customer every time the customer record is updated. So with that quite small, simple primitive that looks like a dictionary is easy to understand, you can build really complex interaction patterns where the UI is being constantly updated in response to events being pushed in on the right side. We also have out-of-process persisted read models. So we have got pretty much all of our application state running in memory in our applications. It's stored on disk in EventStore, and then when we spin up our application, all of our different systems connect to EventStore, read in all the data, and store it in memory and start working on it. Sometimes it's really difficult to write the sort of structures you want to write to query and understand the data. So a really good example of this is doing natural language search. So if you have trades, addresses, users, all this sort of quite structured data, but you want to let users search it just by typing in words, you don't tend to go and write Google yourself. That's a really slow way to get anything done. What you do is you use something like Elasticsearch. So Elasticsearch is a really nice natural language search engine that lets you customize and partition data and filter and query and do really natural queries that humans can understand, right? Not just developers. So what we have is Elasticsearch that sits connected to EventStore. We take events out of EventStore, write them into Elasticsearch, and then we query Elasticsearch for data. So now we have a really complicated internal model inside Elasticsearch that we don't care about at all. We don't understand the complexity of Elasticsearch. We just use it like a little black box. We feed events in and query it and do natural language searching on top of it. It's really, really nice. If you have a relational database, you'll be doing the same thing. You'll be taking things out of your relational database and copying them into Elasticsearch to search on them, or you'll try to use the natural language searching capabilities of your SQL database. Microsoft SQL actually has really good natural language searching capabilities, but Elasticsearch is a little better. And that use of the right technology to solve the right query or read model side of your problem is a really good story for event sourcing, and you see it time and time again. That works really well. So we had requirements, modeling, architecture, and then we had our development challenge. So as I said earlier, we've split our development into 5 streams to deliver the whole application in parallel. People don't tend to build. There's not a lot of people building the sort of product we're building for our client at the moment, and they're very large, complex things. You need 20, 25 developers to do it in a couple of years. You can imagine how big and complex it is. But to do it in any reasonable amount of time, we needed to do a lot of things at once. I don't know how to have 20 developers all working in the same code base at the same time over 2 years. If someone does know how to do that, please come and tell me. Because every time I've ever tried to do that, people just spend their whole life breaking each other's compiles, ruining the build, not being able to do anything, getting frustrated, hating their teammates. What I think we needed to do is split the development apart so that one team or one stream going slowly didn't slow everyone else down. But just because we picked the way to break those things apart, like I said, on day 1 of the project, because we needed to assign people to teams and start moving forward. So we picked these functional areas very early on in the project, and the way people communicated between them was via events. So we divided the world up into 4 different streams and communicated via them only with events. And as I said, we only got the events wrong a few times, and we spent 9 months developing with 15 to 20 developers, all developing in 4 streams, each building huge, really complex parts of their system, but only ever talking about how to communicate with other streams via a meeting we had once a week, and events that looked exactly like the events that we showed earlier, stored in a wiki. We didn't have a .NET contract or anything like that, or a schema stored in a relational database. We just had events written on Confluence on a wiki. And the thing that really blew me away and that made me think that maybe there was something to this event sourcing, event style form of building systems was that after 9 months of development of between 15 and 20 developers, we took a snapshot of all the 4 streams and integrated everything together, and it took us 1.5 days of one developer's time to fix the different versions of events that people thought they had written to and have a fully integrated end-to-end environment that worked perfectly. 1.5 days of one developer's time after 9 months of 15 to 20 developers' times. I was really pleased that it worked, but absolutely amazed that it held together like that. And that comes from the way we had a loose schema, exactly what Dan was talking about. We went schema first rather than code first. We defined the schemas on a Confluence page, on a wiki page, and made it really easy and lightweight, made them really easy and lightweight to understand and talk about. And it held together for that length of time. And we're now another 9 months in. We're about to do another fully synchronized version, and we're actually almost fully integrated at the moment the whole time. And it's again, really straightforward. So that was it, just on time. Any questions? I have here, before I take questions, here is a whole bunch of links for further reading. I don't expect anyone to copy those down. We'll put this up somewhere. Thanks very much. Questions?
Well, do you think for your, let's say your next project, a big project where you have different domains, the next time you will use different event sourcing database for each domain with separate schemas, or will you do the same?
Single event store. I think it will depend on the organization that we're building it for. If their organization breaks down into really distinct business areas, so there's an office in North America and an office in Europe, for example, I would split them apart because I want the software to map to the organization. But if they're all relatively in the same place and thinking about the same part of the domain, then I would do what we've done now.
Another thing, at the beginning, you mentioned the technologies you use, like EventStore, and there's one you say you use to communicate between service. I didn't.
Yeah, crossbar I/O.
What's the difference between using this and use event sourcing, the event source database for communication, because it's events, right? So
sorry, go on.
No.
So this is the language. This is the persistence. This stores the data on disk. This lets you communicate from the front end, so the web page that's running in a browser, with the .NET service that is the write side or the read side. If you write directly to this thing from the client, which you could do, you don't have any business logic to implement the rules. So you need a layer that implements the business logic and aggregates everything together. An individual's UI, so the HTML5 page, should only see my trades. But the system as a whole has trades from lots of different people, and they can't exist just in my system. They have to exist in some service layer somewhere.
So it's only between UI and...
Yep. So that crossbar I/O is UI and server, and they talk directly to EventStore using a .NET API. Cool. Any other questions? At the back, sorry, you were...
Hello. So this architecture, this style to design a system, would you say that you think you can apply it in majority of challenges that you want to implement, or would you hold back and think like, oh, this works well for example, this trading system, but other solutions you think like here it would not work because looking a little bit on the flip side, like where would it break?
I think that it adds a layer of complexity to what you're trying to do. There's no doubt that just because of our past experiences, doing something that we've done before, relational databases, MVC, ORM, is really easy. But to do a system that this big and this complicated and manage to keep up velocity, it's a really good fit. It's also a really good fit for the problem domain. So the system is something called a commodity trading risk management platform, which is something that big commodity trading firms use to manage their entire business operation. So it starts with one end where you have a trader that books a trade, and you have at the other end with maybe 100 different people doing different jobs all the way through the middle. At the other end, settling an invoice and paying someone something. So it's all the way through. And in the middle, you've got this big, huge bit that involves putting things onto ships and onto trucks and putting them into silos. That is a very it actually maps really well to an event-driven world. Lots of stuff happens after lots of other stuff, and you can trace a life cycle all the way through. If you have a system where there's actually a whole lot of unconnected things happening that don't really have anything to do with each other and aren't linked to other things, maybe this isn't such a good fit. I can't think of a good example, but yeah, it's definitely not, I should just take this hammer and hit every nail with it. Yeah, it's definitely approach with caution.
Okay, thank you.
Yeah, at the back, sorry.
Regarding the process manager, I have a question because you don't show there what happened is, for instance, you reserve the credit, and then for some reason the process failed, and then you have a reservation of that. I mean, how do you handle the kind of rollback? Because I mean, when things work, is clear, but with things for some reason turn off the company, I mean, if you reserve some money, you cannot for some reason complete the transaction, the trade. What's happened then? Who is in charge of rolling back and say, okay, free that money?
Yeah.
Rolling back up. So but we sort of have a best effort approach of resuming from where we left on, really. Of course, if the service went down before the message was able to go over the internet and hit the server, then you've lost that message. But whenever we sort of transition to a new state by applying, responding to an event and transitioning, we persist that. And so we're kind of checkpointing what state we're at in that process manager. So in the example that we showed there, obviously the system, the process manager responded to the trade created event and persisted the state of that process manager, which would have been very quick, milliseconds, I guess, over the wire here, and then the service crashed at some point after that. So that state, when we bring the service back up again, we basically play through all of those events again. And another sort of, I guess, piece that we didn't really get into detail was EventStore. EventStore has a thing called persisted subscriptions, and this is essentially like a message queue, which is persisted. And so you can sort of set up this persisted subscription. We have one called trade execution, and we've configured it to be interested in trade created, credit reserved, credit limit breached events. And EventStore knows what events it's dispatched. So EventStore will internally keep a checkpoint of what events it's successfully dispatched, and our process manager will either acknowledge that it's received, processed and received and processed those events. If there's some failure, it will put it into what's called a dead letter queue, or it's called parking in EventStore. Or the server can also choose to skip a message that it doesn't know about. So basically, you have that side of things in EventStore as well, which manages the whole message queue side of things. So in our example there, where we crashed the trade execution service, EventStore knows that it was not able to successfully dispatch the credit reserved event, I believe, in that case. So it just, when the service connects again, it knows what events need to be dispatched, and the process will carry on from that point on. Does that make sense?
But the question is, to answer a slightly different question, one of the challenges of an EventStore when you have an append-only database is that if you make a mistake, it's actually really hard to fix your problem. So if you have a relational database and you do something wrong, you just go to production, you open up SQL management server, you log into the database, you update the record that's broken, you commit the transaction, and you go home. But in an EventStore, you have to have already built an event that you can insert to compensate for the error you introduced before. You don't know what errors you're going to introduce. How can you create events to compensate for things you don't know you're going to do? I might come back in a year's time and tell you this was a terrible idea. But right now, it works. But that is a real subtle thing to manage. One more question over here.
I actually have two questions. First, how well EventStore scales? And the second question, are there situations when there is a race condition between two different events? So for example, like on the situation when you showed, when you tried to buy the currency and the worker was down, could it be possible like at the same time the price of the currency like relation will be changed and
Yep.
this event will be processed while the buy event will be not processed?
Yep, yep. So first question is how well does it scale? It scales just fine for our system. It's not super fast. We have performance tested it on the cloud, deployed to fairly impressive infrastructure running on the cloud. It runs in a clustered environment configuration, so you have 3 nodes all achieving quorum. It has a raft cluster inside it, and that was doing 40 to 50,000 messages a second, which is not a huge amount, but it's still quite a few. On the second question, could it get out of sync? Could there be a race condition? That comes back to the consistency boundaries. If it's really important that the trade that you do match is against the current price of the market, what you have to do is bring those two things together in an aggregate. And the process that we were starting to build with the credit reserved amount is actually a good example of this. So here we go out and try to reserve the amount of money on your account to see if you can actually do the trade. Then we come back and see whether we still want to do the trade. Just because you've reserved the credit doesn't necessarily mean that we still want to do the trade. So that's the place where you check against the little bit of consistency to make sure it's still in sync.
Thank you.
Hi. Have one question related with this one, and another with something else. So are you somehow ensuring that when an aggregate is processing a command, is processing once a time in terms of achieving consistency, or you get to that point when this is a problem and you have to somehow check versions or something like that? And are you already in a situation in which you have to manage time events in terms of timeouts, for example, or in terms of events that you want to happen in the future because of some kind of processes? Do you have any kind of actual infrastructure for this?
Sure. So first question is, do we have multiple? So in our system, we have multiple events, multiple write instances, so you can issue commands against multiple instances. So EventStore does give you some transactionality guarantees, and it gives you them on the aggregate boundary, basically. So the API lets you say when you write an event to an aggregate, to what EventStore calls a stream, you can say, I expect the last version that I wrote that is on the stream to be version 5, so this should be version 6. And if it's not, tell me about it. So it's like optimistic concurrency. If someone else has gotten before and written another message and the stream's now on version 6, when you write your event that you think should be being applied to version 5, the system will reject it and tell you that there was a problem. So that gives you guarantee. You retry, yeah. And you read the event, you say, what you do is you rebuild your aggregate. Can I still apply the command? Is it still valid to go on top of this newly formed thing? Because when the user issued the command, they were looking at version 5 of whatever it is. It's a business decision now. Should I retry, or should I go back to the user and say, something's changed, you need to take care of the problem for me, have a look and hit submit again if it's relevant? So that's one solution. The other solution is to ignore the versioning and just say, I don't care, right over the top of it. Or not right over the top of it, append it anyway, and now we've got 2 events that happen against inconsistent versions of the entity. Is that a problem? Depends on your business problem. And sorry, the second question was, again, remind me? Oh, you didn't ask the second question, that's why I don't remember it. Good.
Yeah, it was about time events.
Oh, yeah, sorry. Timing is really awkward. For things that happen on a large time scale, like every day, one thing we're not doing yet, but we will probably do in the future, is actually inject time as an event into the system, so that when you have a process manager and it says, well, every time a new day occurs, we do these things, it's not looking at the clock up there, it's looking at the clock in the system. And so you inject new day as an event, and everything that needs to do something when there's a new day sees that event, goes off and processes all the things. For things that are a much smaller frequency, like every second, for example, it's just not practical to insert an event into EventStore every second. So you have to take more care about having a process manager that has state in it, that is processing things in a serial fashion, and that understands when it expects to have done something, when it rehydrates itself after it's recovered. So you can imagine that an event a process manager sees an event, waits 30 seconds, and if it hasn't seen something else happen, raises an error. So when it crashes and recovers, it goes back to the beginning, plays through the events, waits to see 30 seconds, starts a new 30 seconds, and sees if it hasn't seen the event come through. So you have to balance the engineering to make sure that it all makes sense, and it's quite complicated. It's to make sure that those sorts of time-based things are resilient is quite difficult.
Okay, guys. You can ask afterwards. Thank you for the talk. So
Thank you very much. Thanks, guys.